Hey guys, welcome back to another video of me solving a coding interview question. So today's question is very interesting because a few days ago I was talking to one of my friends. I don't think it's a few days ago, I think it was actually yesterday. So he was telling me about this question he was solving, and he was like asking for my opinion on how I would solve it. So the question is, you're given an array of elements, and every element occurs an even number of times, and there's only one element which occurs an odd number of times, and you should find that one element. So I was telling him about how I would like throw everything into a hash table and count their occurrences in the hash table, and then I'd later count the value sets in the hash table, or the key sets, I think. I'd determine which key set occurred like an even number of times or an odd number of times, and I'll return like the very first one that I see that occurs an odd number of times. So that's pretty much it. And I also told him that I would probably sort the array. So I know that if I sort the array, like all the elements that have the same value are going to be right next to each other. So I'm going to count their occurrences, and after counting their occurrences, then I would modulus the count by 2. And if I get 0, I know that that element occurs like an even number of times. And if I get a number other than 0, then I know that that element occurs like an odd number of times. So that's pretty much it. So I wanted to solve this question, and I was looking for a very similar question to it, but I couldn't find it. But I found one that is remove, or not remove element. It's single number. Yeah. So this is it. So it's very similar to that question, but this is the closest one I could find. So let's dive right into it. You're given a non-empty array of integers. Every element appears twice except for one, and you should find that single one. So how are we going to do this? So you could naively do the hash map solution where you put everything into a hash map and then count their values, but you know that almost all the values are going to have 2 occurrences except one that occurs once. So you should really focus on finding that one element instead of putting everything into a hash map and then counting their values when you know for sure that almost all the values are going to have an occurrence of 2. And if you read Cracking the Coding Interview, there's a section that talks about optimization and steps to optimization, and that's the BUD technique: bottlenecks, unnecessary work, and duplicated work. So counting every value when you know what their occurrence is going to be almost maybe counts for duplicated work. So you might move to another solution where you want to sort the array and have all values like right next to each other. But that's also going to be a little costly, not on space because you could do it in place, but a little costly on time because you're going to have to do a lot more computations and finding which occurrence is even and which occurrence is odd. Sort of like that. So I think that was a bit more of ranting. Let's dive right into the solution. So how would I do this? So we have an example of 2, 2, and 1, and we should return 1 since 1 appears only a single number of times, just one time, and 2 appears twice. And we have another example, 4, 1, 2, 1, 2. 1 appears twice, 2 also appears twice, and 4 occurs just one time. So we should return 4. So when I look at this, a very cool data structure that we could use is a hash set. So let's take a look at this example. We have 2, 2, and 1, and we want to return 1. So what we could do is we could create a hash set, which is just going to store one value. And let's say this is our hash set. And then we iterate through the elements in the array. And when we get to 2, we store 2 in the hash set. And if we find another instance of 2, and let's say we're at index 0 and we store 2, and then we get to index 1 and we find another instance of 2, what we could do is we could remove 2 from the hash set, right? And then we go to 1, that's at index 2, and then we add 1 to the hash set, and now we're at the end of the array. we're done traversing the array. So the intuition behind this solution is that at the end of everything, there's only going to be one element in the hash set, and that's the element that occurs only once. Because come to think of it, if we find an element that occurs once, we add it to the hash set, and if we find another element of the same instance with the same value, we remove it from the hash set. So every element that occurs like an even number of times would definitely be removed from the hash set, and in this case it's 2. And at the end we're only going to have one element, and that's the one that occurs only once. Let's take another example. This one is going to be a little like what you'd actually get in an interview setting. Let's say 1, 2, 3, 2, 4, 3. I think I need another one. Yeah, 4. Cool. So create a hash set. Cool. And then we iterate through the elements. And when we're at 1, is 1 in the hash set? No, it's not. So we add it to it. And we get to 2, is 2 in the hash set? No, it's not. So we add 2. Is 3 in the hash set? No, it's not. So we add 3. And then we get to 2. Is 2 in the hash set? Yes, it is. So we erase this instance of 2 in the hash set. We remove it from the hash set. And then we get to 4. Is 4 in the hash set? No, it isn't. So we add 4. And then we get to 3. Is 3 in the hash set? Yes, it is. So we take out 3. And then we get to 4. Is 4 in the hash set? Yes, it is. So we take it out. And at the end of everything, we only have one element, and that's an element with a value of 1. And then we return this. So that's pretty much what it is. And the good thing about using a hash set is that you could look up its values in constant time. So that's going to be a very inexpensive operation in time. So let's dive right into the solution. So what we want to do is create a hash set, and we're going to call this set, and it's going to take an integer, and let's just call it set. New hash set. Close this guy, and we make sure we import the libraries. So import Java util, all of them. Yep. So now we have to iterate through all the values in the array, and we could do that with a loop, ideally a for loop. And you might want to use the for loop with the iterator with I, where you store indices. But we don't really need indices in this case. We actually need their values. So I'm just going to do the simplified version of the for loop, and that's for an int num in nums. Very bad formatting. Cool. So for every integer in the nums array, we want to do 2 checks. First, we want to check if the number is in the hash set, and then we want to check if it's not in the hash set. So if it's in the hash set, and that's if set.contains, I think that's it, right? Set.contains num. We do something. Just going to write do something. Now I can't spell something. And else, if it's not, then we do another thing. Cool. So what did we say? If it's not in the hash set, then we add it to the hash set, right? If it is, then we just remove it from the hash set, right? So if set.contains num, we could do set.remove num. Otherwise, if it's not in there, so we just want to do set.add. I think you could do add a push and num. And that's pretty much it. And at the end of everything, we want to go through all the values, in set. Ideally, there is only going to be one value in the set, because if the input is right, in that it only has one element that appears once, we should only have one element in there. So let's just return whatever element we have in the set. So we're going to just say for int num and set, we just return that number. And what should we return if we couldn't find an element that occurred only once? Does the question say? No, it doesn't. It doesn't say. So let's just return 0. So if we couldn't find anything that occurred only once, we just return 0. And that should be pretty much it. I'm going to try to run this, and let's see what happens. Always missing my semicolons. Cool. It works. So submit it. Great, it works. So when I look back at the description, it says, could you implement it using without using extra memory? I think we definitely could. We could implement it without using extra memory, and this extra memory is a hash set. So if the length of this video is really long, I think I could abstract the next solution to another video. I'm going to record it right after this. But let's quickly talk about the time and space complexity of this guy. So the time complexity is definitely going to be O of n, because we're going through every element in the array. And for space, I think we're going to go through O of n in the worst case. So say, for example, we had an input that only has like one occurrence of every element, right? We're definitely going to add all of them into the hash set. So that's going to be O of n. That's in the worst case. In the average case, though, let's take a look at one of the examples that we have. So we have 2 and 2 and 1. Like, if the elements are contiguous, if the elements with the same value, if they're contiguous, like they're right next to each other, we're going to store at most one element in the hash set every time. Because when we store the element, we go to another element and we find out that it's the same value. And we remove it, and then we go to another element, it's a different value, we add it, we go to the next element, it's the same value, we remove it. So we're only going to have like one element at a time, as you could see in this example. But in cases where like they're scattered around the array, you can't really predict how much elements you're going to store at a time. So I'm not going to safely say it's O of n space. So your time complexity is going to be O of n. Space complexity is also, I'm writing down, it's also going to be O of n. So that's pretty much it for this algorithm. I'm going to try to do the one with the no extra space, extra memory, and I'll post it right away after this. So that's it. If you like this type of content, please subscribe to the channel. I'm going to try to keep up with my schedule of posting 3 videos in a week. I know it's really hard, but I'm going to keep up with it. And please comment down below if you think there are ways we could have made this work better. Also, smash the like button for the YouTube algorithm, and make sure you share this video with your friends and family who might be preparing for their coding interviews, or just share it around the community, spread the word out, and I'll see you in the next solution. I'm going to try to do it right after this. So bye. I'll see you soon. Bye.